Good evening everyone, I hope you are fine. So this is the last video for Newton's laws in consultative tutorship for Newton's laws. The last time we did the what we call the horizontal surface questions, and then right now we're gonna do the inclined plane questions. So I wrote this question in June this year, and this question is for 2015. There is a question that is here. You see, they are the same, just that they changed there and there. And right, unfortunately, I don't have the statement here. It was supposed to be here, so I don't know where it is. So yeah, it's fine. So I will just use this one because this is the original question. So here they changed the things. Check it. My tension is 8 marks, and here it is 5 marks. And there's even a definition for a kinetic frictional force. You see, so I'll use the statement here, but use the questions that are here. You see, so that I can save time. Okay, so let's read the statement in the diagram below. You see, it was easy because right now they want the kinetic frictional force F is equals to mu k times n. You get your thing, and it's fine. You see. Okay, let's start. In the diagram below, a 2 kg block is connected to a 1 kg block by means of light inextensible string, which is the tension. The blocks are pulled up an inclined plane, which forms an angle of 28 degrees to the horizontal, cos theta. The sides of the blocks which touch the inclined plane have the same area. Okay, so that is the statement. We are now continuing. I don't want to consider that one because it has many marks and it will be like I don't want to do that. So I'll focus on the original question paper that I will put in my thumbnail. So the another statement goes like this: the kinetic friction force Fk between the 1 kg block and the inclined plane is 4 newtons. Okay, so since there's a force applied, obviously you know that there's a kinetic friction. That's what you must know. While the kinetic frictional force between the 2 kg block and the inclined plane is 8 newtons. Okay, so they both have the kinetic frictional force. Okay, so 1.1.1, draw a free body diagram showing all forces acting on 1 kg block. Where's my 1 kg? It is here, and it is out of 5 marks. So let me do it. The first force, this is question 4, ne? So I'll just write question 4 like in the thumbnail. Because you see this question 4. So 4.1. So you know what the first force it is what? The weight. Guys, always use a ruler when you're drawing these things. Just that means I don't have an extra hand to do this. Always use a ruler to draw these things. Okay, so the second force is the normal force. You know what in the inclined plane the normal force acts perpendicular to the surface. Then there is a tension here. That is where like that. So it's gonna be like this. And there is a force applied which is facing that side. So be careful. You have to make sure your tension and your force applied are straight, they match. And then the force applied is a kinetic friction, so which means that I have to increase the dot and then do like this Fk. So when you're using a ruler, you have to make sure that the lines here are equal. Like you don't have to make the other one like this, whereby my force applied is like this, then my tension is like this, whereby the tension is the one that is pulling the object, the block. So this is how we do it. So 1 2 3 4 5 marks. 4.2, Newton's second law. You'll get it on your own. You know it. You know it. When a net force is applied on an object, the what will accelerate to the direction of the net force, then acceleration, blah blah blah, the real stuff. So they want the magnitude of the tension in the string. So we know we must consider the two blocks. So I'm gonna say for the 2 kg block, so I'm gonna do F net equals to mark. Already I know what I have a mark. So let's do that. Okay, let's do the forces acting upon 2 kg. This is my 2 kg. And so let's do the free body diagram for 2 kg. Let's do it somewhere here. The free body diagram on the sorry guys, I have sinuses. So let's do the free body diagram for the 2 kg block, which is here. You see that is here. So do you know what is the force? The tension and the kinetic friction, because the tension it is this one, which is like that. So let's consider the forces acting upon the 2 kg block. So since this is an inclined plane, I'm gonna take 2 forces only. You don't consider the normal force on your calculation. You consider Fn only if your block is hanging. So there is no block that is hanging, so we are not considering the 2. So which means we're gonna use the kinetic friction and the tension. You must know that you use the weight only if it is hanging. You don't use the normal force. You don't use it at all. You don't use it at all. Okay. So okay. So let's continue. Come here. The tension is facing where? To the right hand side. Between I have the left and the right hand side. So it will be a positive tension. So it's gonna be tension minus kinetic friction is equals to mass, which is 2 times acceleration. Then is equals to 2a. My tension is unknown, then minus 8 newtons I was told. Then I can say tension is equals to 2a plus, okay, I forgot something very important. Forgive me guys. Let's start afresh. This is physics. It's not like you have to be correct at all times. So let's start again. Let's start afresh. So this is an inclined plane. I said they are abstract forces, so this force must be there. So it's gonna be tension minus kinetic friction minus Fg parallel, which is equals to mass times acceleration. Fg parallel, it is the force that is acting parallel to the surface. I need to know to have this. We have this in our inclined plane. So Fg parallel must be there because it is acting parallel to the inclined plane. So we must always include it. We don't include the normal force, the Fg perpendicular, because it is with the normal force. Okay, so let's continue. So it's gonna be tension minus 8. Then let's substitute. Fg parallel is mg sine theta, which is equals to 2 times a, then 2a, then t minus 8 minus, forgive me guys, I'm not feeling well today and I have to finish these things. Okay, so let me do it on my calculator. You see, you do it like this. I need to learn it is minus 8, so it must be minus 8 as it is. So it's gonna be t minus 17,201 is equals to 2a. Then that one I'll take my 17,201 to the other side. So it's gonna be tension is equals to 2a plus 17,201. Okay, so this is my equation 1. Let's consider the second equation. So it's gonna be the 1 kg block. F net is equals to ma. Then now I have my force applied, and this force applied, it is not at an angle. These 2 blocks are the ones that are at an angle of 28 for the Fg parallel and Fg perpendicular. But this force applied is not at an angle. So you're just gonna say force applied only minus tension. Let me just say minus kinetic friction because it was given. So minus Fk minus Fg parallel. This one must be always there. Minus tension is equals to A, because 1 times A is A. Okay. So let's continue. My force applied is 30 My kinetic friction is 4 minus 8 minus 4 minus mg sine theta minus t equals to a. Okay, so let's continue. It's gonna be there 26 minus 1 9,8 sine 28 minus t equals to a. So let's do it on our calculator. What it is 21,39, so it's gonna be 21,399 is equals minus t is equals to a. Guys, another thing that you have to know, don't simplify your things before getting to the final answer. You might get the wrong answer. See, so leave your things as it is, because many people are gonna say 21,4. So we are continuing. So since this is my equation 2, I'm gonna substitute equation 1 into 2. So I'm gonna say sub 1 into 2. This is math, so I'm gonna say 21,399 minus t is equals to a. 21,399 minus open bracket 2a plus 17,201 open close bracket is equals to a. Okay, and then what am I doing right now? I'm gonna open the bracket. So 21,399 minus 2a minus 17,201 is equals to a. Then I do my leg times. 21,399 minus 17,201 is equals to a plus 2a. A plus 2a is 3a. Then this one's minus 2,201. I get 4,198. Let me divide everything by 3. I divide everything by 3. Then I get 1,399 whatever. So my acceleration is equals to 1,3999 whatever. So which means therefore, since it is my final answer, I can simplify it. Correct it to do the decimal place. So my acceleration is 1,4 meters per square seconds. But the equation wants the tension, so I'm gonna choose between the two equations. So let me take this one. So t is equals to 2a plus 17,201. Then t is equals to 2 times 1,4 plus 17, 201. Then tension is equals to, let's check, 2 1,4 plus 17,201, which is 20,001. Therefore my tension, it is equals to 20 newtons. That's how we get our things. The only difference here, it is because we include the FG parallel in the inclined plane, whether it is applied or whether it is not. Every block on the inclined plane has FG parallel. Okay, so I want to show something here. This is my grade 11 stuff, so I can do anything I want with it. So if it happens that this 1 kg was applied at an angle again, so we are gonna say force applied, since it happens that this thing is applied again at an angle, we are gonna say force applied cos theta, because this is the ratio for the adjacent side of this thing. So we'll do more videos as time goes on, guys. So let's conclude. Let's do this one. The 1 kg is now here, the 2 kg is there. So they're saying they interchanged the blocks. So how will the acceleration of the same system change, right? Only increase, decrease, or remain the same? It will remain the same. So 4,4.1, so it will remain the same. Okay, the reason I'm saying it will remain the same, it is because check, the 30 newtons was pulling the very same 1 kg and the very same 2 kg, so there's no difference. There is no difference because it is just the same. And then how the tension in the string connecting the two blocks change, it will decrease. I will tell you why. So it will it will decrease. The reason I'm saying this, it will decrease, it is because check this string here, it is being connected between 1 kg and 2 kg. So if this 2 kg, and if the 2 kg was here, then the 1 kg was here, then the tension was 20 newtons. So now they were interchanged, so the tension will obviously change. This, since now our force applied is pulling the 2 kg first, and then the 2 kg is pulling the 1 kg, so the tension will change, because this 1 kg was using 20 newtons to pull the 2 kg. This 2 kg now is going to use a greater force to pull 1 kg, since 1 kg is just like less than 8, I understand. So yeah, thank you guys for your time, thank you for your supporting me, thank you for everything you've done for me. So next year I'll be busy with things, I still have to do more videos. We'll be busy.